Hello, everyone. We are looking at phase 5, chapter determinant, exercise 1. And this is question number 35 for us. So, what is the question is again, we have to use the property of determinant. It is one of the good questions. It has something here, and we have to prove AB plus BC plus CAQ. All right. So, the question, I should say, this is a star question because the strategy that we are going to discuss now will be useful whenever we see A, B, B, C, C, A in the question. So there will be multiple approach to any question, but just see how can we do it faster or better here. So one of the approaches has been discussed here in the solution. I'm going to discuss another solution so we can figure out whether that is convenient. So what I'm going to do here is I'm going to introduce A here and B here and C here in the 3 columns. So essentially what I'm going to do is I'm going to change the row modification. So A R1 and R2, I'm going to make it as B R2, and then I'm going to make R3 as CR. So I'm going to introduce the 3 things here and let's see what it is. So it will be minus ABC, AB square plus A AB square ABC and AC square plus ABC. Now here B I have introduced, so A square B plus ABC. यहाँ पे C है, so A square C plus ABC. Here minus ABC and BC square plus ABC and minus ABC and C is here. So CB square plus ABC. ABC. Okay, so this has been done, so I am dividing by ABC. So the reason for that is the next step we will understand. Now I'm going to factor out A from here, B from here, and C from here. Okay, why I'm doing it? By practice, we will understand that this particular step will actually simplify it much faster. So I am going to factor out these things, and the determinant then becomes, because ABC has come out, so ABC will take care of that. So the determinant will become, I have taken out, so minus BC and from, okay, I'll just do this so that it is less confusing. AB and plus BC, then AC plus A has come out, so BC. So I have factored out A from the first column. So if we want to write it, so first column is C1 by A, second column is C2 by B, and third column is C3 by C. So this is what I am doing. So from here, AB plus AC, and then minus AC, and then from here, CB plus AC. Okay. I'm going to write on this later, we can delete. Okay, so AC, C I've taken out, so AC plus AB, then BC plus AB, and minus C has been factored out, so A. Okay, so this is, from here I have factored out C. So just check once again, AC plus AB, BC plus AB, and minus AB, all right. So after this, again, there can be many approaches, but I am trying to get to AB plus BC plus CA. So the first thing that comes to the mind is that we are going to do C3 and C3 minus C2. C, this modification I'm going to do. So AC and AB, the first element will be 0. BC plus AB minus AC. So I am going to get AB plus BC plus CA. So this is useful for us. And again, this is nothing but again AB plus BC plus CA. So again, useful, very useful. So AB plus AC minus AC and BC plus AC. And here we have minus BC, AB plus BC, and AC plus BC. Okay, so again, the property of determinant is going to help us. From here, we can factor out AB plus BC plus CA outside. So we will get AB plus BC plus CA has been factored out, and the determinant will reduce to minus BC, AB plus BC, AC plus BC, and AB plus AC minus AC, BC plus AC, and 0, 1, and minus 1. Okay. So we have got 1 here. How do we get the other one? So mm, AC plus BC, AB plus AB. Okay, I think this is simpler. We just add all the rows. So row 1, let's make it row 1 plus row 2 plus row 3. Okay, let's make it so AB plus BC plus CA. That is the common factor. If we add everything, what am I getting? AB, AC, 2 times BC, but 1 minus BC. So I am getting AB plus BC plus CA. Okay. What am I getting here? AB, AC. So AC gone. So AB, AC again. Same thing. AB, BC, AC. AB plus BC plus AC. And here I'm getting 0. So, okay. So now AB plus BC here. AC plus BC here. Looks like our problem is going to be solved. So BC plus AC here. And 1 and minus. Fine. Now, here again, we can factor this out. So it will come out as square, and 1 we are going to get. Yeah. 1 and 1 and 0. So we are going to get 1 and 1 and 0. Okay. Can we add these two so that we get another 0 here or here? Let's do that. Mm, okay. All right. So we will add here. What I'm going to do is we will say R2 is R2 plus 3. So R2, so first element is 1, 1, 0. Maybe plus piece plus. Okay, or I could have just created this also. I think this is similar. C1 is C1 minus C2, or C2 is C2 minus C1, because I want to have 0, 0. It just looks simpler that way. AB plus BC plus CA whole square. AB plus BC plus CA whole square. And our first column is AB plus BC, no change here. AC plus BC, no change here. But the second one, 1 minus 0. And then AB plus BC. So I get AB plus BC plus CA here. And BC and AC, 0 here. All right. So 0, 1, and minus 1. Now you can see this is going to come out as AB plus BC plus CA. So AB plus BC plus CA whole cube. All right. So 1 AB plus BC here, and AC plus BC here, 0, minus 1, 0, 0, 1, and minus 1. Uske baad nothing is left. Expand from here, 1. So this whole thing, this whole determinant is going to be equal to 1. So finally, this is the value. So just a quick recap, what happened? Whenever we are going to get A, B, B, C, C, A, so try doing this, factor out multiply A, B, C. So introduce A, B, C row wise, take it out column wise, so that our A, B, B, C, C, A, the desired elements are created. And after this is a very, very standard question. What we have to do, we have to just see whether things get added and we get AB plus BC plus CA. So once we are going to create, able to create, we keep factoring it out. We keep factoring it out. So by doing desired row and column modification, as in with practice, you'll get. I think you're going to get better than me also. So just add things together, AB plus BC plus CA, factor it out, factor it out. So finally, this is what you are going to get. This is the answer. Thank you.